In this video here, we're going to look at sketching a logarithmic graph. In this example, it says sketch the graph of each of the following, labeling asymptotes, axial intercepts, and stating the domain and range in each case. For this example, we'll be sketching the graph of y equals log base 10 of 3x. Now the first thing that I notice here is that there is only one type of transformation in comparison to the basic graph, which is y equals log base 10 of x. So this means that our graph follows quite a standard basic graph where the asymptote is a vertical asymptote at x equals 0 and our graph branches out and increases as we go further to the right. We can definitely find the x-intercept here, and there is also another value that we need to find, so we can definitely do that. This 3 here is indicating to us that there is only a dilation from the y-axis by a factor of 1/3. Because of this 3 is where it's situated and it's associated with the y-axis, it's dilated by a factor of 1/3. So let's go ahead and we'll find out. First of all, we'll put in our vertical asymptote. Now you can see that I've drawn the vertical asymptote right beside the y-axis, because just in case if I do draw it on the line, it might look like it's not there. So a slight offset is absolutely okay, but our main feature is that we write the formula next to it. Next, we're going to find our x-intercept, and we can find our x-intercept here by letting y equal to 0, which means that we have log base 10 of 3x equals to 0. If we take the log base 10 across the other side, our base stays the same as 10, and the 0 becomes the power. 10 to the power 0 is 1. And so if we solve this, we divide both sides by 3, and our x-intercept is 1/3. I'm going to label that in, and I'll draw the coordinate later. We do want one more value to be placed in here, and just thinking about how we can find a nice value, what we can do is have a look here. It's a base of 10, so if this here, ideally we would want this bracket here to equal to 10. So whatever's inside that bracket there, if we make it equal to 10, then we can make it a nice number. So if we make x is equal to 10/3, now let's reverse engineer this. If we make x equals to 10/3, our y value is going to be log base 10 of 3 times x, but our x is 10/3. What's going to happen to those 3's there? 1 is in the numerator, 1 of the 3's is in the numerator, 1 is in the denominator. They cancel out and it becomes 10. Log base 10 of 10 is equal to 1. So our coordinate here is quite neat. It's 10/3, 1. 10/3 is approximately 3 1/3. So 3 1/3 is somewhere around here. That's quite far. I'm going to label it in anyway. 10/3, 1. And essentially what we're going to do is connect those dots. The reason why it's so steep is because we have a base of 10. So the rate at which this increases bends and changes very quickly. And it continues to grow. Make sure that your asymptotes are approaching the asymptote. Or, sorry, the graph is approaching the asymptote. So we've got one point in, another point in, we've got the asymptote and the graph. Last but not least, the domain. Our domain here, our lowest x value starts off from the the y-axis, which is an x value of 0, and it continues to go further to the right, which is positive infinity. Our range starts all the way down at the bottom here and continues to increase as we go to the right, which means that the lowest point is negative infinity and our highest point is positive infinity. So there we go, a log graph. Don't forget to pause, rewind, and replay if you want to rewatch.